Hello, hi, my name is Abdul Qayyum Maharum and I will introduce you guys about my final year project system. First, I will pitch you about my project to give you guys an idea what is the purpose of my system, which is artificial reef site selection suitability detection and coral survivability prediction based on selected features. Coral reefs are extremely complex ecosystems characterized mostly by complex interaction between biotic and abiotic components. To secure the overall interaction, it is important to protect the coral ecosystem. This study attempts to address the issue of coral conservation by suggesting a suitable site to place an artificial reef and determine the coral suitability. We built a fuzzy expert system model integrate with big data technique to gather a vast amount of data to help the ocean coral conservationists and researchers in determining a right action so that the coral will stay healthy and breathing. Four input variables involved, which are seawater temperature, pH value, depth of the ocean floor measured from the surface, and the salinity of seawater. Each variable was assigned into several respective fuzzy values and construct the rules based on the observation and true knowledge provided by local reefs researcher. I will show you the rules later in the coding, and subsequently we construct the function of each fuzzy component, which is involved fuzzification, rule evaluation, aggregation, and defuzzification. To demonstrate the system, we integrate a huge volume of dataset in which we acquired from NOAA, which is integrate, clean, and remove outliers earlier. We then plot those datasets into world map. Each of the plots will act as an input combination of our proposed fuzzy expert system that will estimate the percentage of artificial reef placement suitability and coral survivability. As for the future work, the system can be improved by getting a real-time and current data as the input. Therefore, the efficiency of the system and accuracy of the result can be improved. And now I will show you the system. Okay, this is the system interface which involves the world map, and at the bottom of it is the fuzzy engine. Um, is the fuzzy engine to decide the output of the system. It basically to show that how the system works. Okay, look closely. Okay, for the user will click their what where they want to put their artificial reef. Okay, when you click any of the coordinate, it will show the coral's name and its species, which is I only put um, Madrepora oculata, which is I plot all of the Madrepora oculata, which is some of them is at the same coordinate, so it's redundant, it's duplicate here. Okay, and then for this is the data that I put in the system, which is it will plot all the coral in the world map. Okay, for the artificial reef placement suitability and coral survivability, user need to put pH. Okay, see, okay, you can see at the bottom of it how the system predict. Okay, uh, this and then it shows 91.6% suitability for placement of artificial reef, and then it will also shows the survivability if they put the survivability of the coral around the artificial reef, which is 83.45%. This indicator shows how the system works. And then same, you can just click here and just input the pH, and it will shows the result for the artificial placement stability and the coral survivability. Okay, at the bottom of it is this is the aggregation, and the coding, it also have the uh, rules of it. Rules something like, okay, the temperature is very cold, depth is very deep, pH is medium, which is what we input earlier, which is 7.5 pH value, which is 7.5 pH, and the salinity here 34.9 PSU. Okay, this is the rule aggregation, and this one is the output is based on center of gravity, which is we also known as defuzzification. Okay, we move forward to this is the data we acquired from NOAA. Okay, it gives us this is the coordinate for the coral, the depth, observation year. This is we also can know the condition for the coral here. The condition, temperature, salinity, and the data provider, and where is the station. Okay, this is the, as I said earlier, I will show you the rules for all the to predict the placement stability and coral survivability. Okay, this is the rule for coral for survivability for the coral. Okay, this is the survivability for low survivability, and this rule is for medium survivability, and this one is high survivability. And for the artificial reef suitability, this one is the very low rule, low, and then moderate, high, and very high. You see, okay, the rule is validated by the expert. By the expert, we consult from Nurul Arba'in, which is former uh, diver in UMT, University Malaysia, UMT. And then, okay, this is how the this is how the COG, how we determine the COG. This is the code, and this one is for, yeah, this one is for the suitability. Okay, I basically just put the um, this graph by canvas.js.com, which is helped me to represent the fuzzification graph. Okay. Okay, this is the linear equation formula. Okay, and this part is for the map. We basically can change how the map interface, terrain, or anything else, what you want to see for the interface for the map. Okay, that's all for my system. Thank you.